Right, students. So we'll discuss one more problem now. This is one pulley problem is there. We did this pulley problems now in Newton's laws of motion. Also I did one video on the shortcut method onto this one, how to calculate the tension and how to calculate the acceleration. But there what we considered now, we considered that this pulley was ideal. This pulley was ideal. Ideal means massless. But here what we are going to consider now, therefore here mass of this pulley is given onto this one now, therefore it is not massless now. Then therefore to rotate this one now, to rotate this wheel also certain amount of force it will be needed onto this. So therefore if you are including the mass of this pulley, then how to solve these problems now? Let us do one simple concept now, simple one now. So let us see here now, downward force. What is the downward force now? That is nothing but a 2 mg is the downward force. So due to this one now, tension is nothing but a suppose T1. Now due to this one now, this force is how much now? Mg. Due to this one now, tension is T2. Right? Here tension is not same onto this one. Now therefore here what we are going to do now, we are going to rotate this one now. Therefore this one, what it is doing now, this tension now, it is making to rotate like this, and this tension now, it is making to rotate like this. Clear? So therefore in which direction it will rotate now? This side is heavier mass no, so this side torque was more, that's why it will be able to rotate in this direction. You have to consider this rotational of this one also, you have to consider torque of this one. Then suppose it is going downward with an acceleration and it is going upward with an acceleration. We can write down the equations now. What is this equation now? Downward, that is nothing but a 2 mg minus T1 is equals to 2 ma. We already studied free body diagram now, how to write it now in Newton's laws of motion. Now here we can write it now. This side is going means T2 is greater. So T2 minus mg, it will be equal to ma. Not only this one now, therefore we need to write it here, this torque. What is the torque here now? This T1, what it is making now, making to rotate anti-clockwise. This T2 making to rotate in clockwise. Net torque is how much now? Net torque no. So force into perpendicular distance. So therefore T1 into force into perpendicular distance no, into therefore R. Where it is a perpendicular distance, this distance is nothing but a R, radius of this one no, minus T2 into R. So torque, net torque no. So net torque no, that is nothing but a I into alpha. Clear? So therefore what you can write it now here, T1 minus T2, so into R, it will be equal to moment of inertia into alpha. Alpha is, we can write down A is equals to R alpha. Therefore alpha is equals to A by R. Sorry, here no, this is R, we have to write it. This is R. Right? So we know these equations no, therefore these two equations we know it no, therefore we can calculate T1 minus T2 in this one no, T1 minus T2, then you can eliminate into this one no, then you can solve for acceleration onto this one no. Clear? So you can solve these three equations no, therefore so these three equations you can able to solve it no, but I will give one simple trick for this one no, very easily you can calculate it onto this one no. So first what is the trick here no, trick. Very simple formula, acceleration. What is an acceleration here now? Acceleration is nothing but a total mass by total force by total mass. So what is the total net mass, net force here now? Downward force is, total net force is how much now? Therefore it will be 2 mg. So therefore 2 mg net force. That is, we can write it as directly. So net force by, therefore total mass of the system. So what is the total net force now? Here downward force is nothing but a 2 mg is there now, and this also acting, right? Both are acting, therefore, so what you have to write it now? Therefore this both are acting onto this one no. So you need to total net force how much now? This side it is pulling on, this side is pulling onto this, minus, therefore it will be mg divided by total mass of this one is how much now? Total mass. So therefore here Why minus? No, because this is making this to rotate here. No, this is making to rotate here. No, therefore this is making different acceleration like this. Therefore total net force onto this one, it will be here, right? Actually here this total 2 mg plus mg, it is acting upward, but here we are making to rotate it. No, this is trying to make toward this side, this is trying to make toward this side. That means both are acting in opposite direction. That's why we written as minus here. No, therefore total mass is how much now? Therefore it is 2m plus m plus due to moment of inertia of this one. No, so therefore you can write down moment of inertia nothing but m r square. M is equals to I by r square. So I by r square. So this is your formula. You can rewrite it as, so this formula you can get by solving these two. You can calculate the problems here now, right? If you remember this formula is enough. How I got it now? You solve these two equations, you will get this formula only. Now we will write it now. We will simplify this question here now very quickly. Therefore here, so what is given now? Here it will be 2 mg minus mg is nothing but a, so mg by, therefore 3m plus, what is this one now? We will take it as like a disc, no? Disc, right? This wheel, right? So this will take it as this. Now what is the moment of inertia? Moment of inertia is nothing but a mr square by 2, this disc, no? So therefore I by mr square means is nothing but a m by 2. Clear? So how much will get it now? mg, therefore it is 6 plus 7, 7m by 2, it is into 2, therefore will get cancelled. Therefore 2g by 7 will be your acceleration, so of this problem now. You understood, no? So therefore how to solve these problems, no? So very easily, so remember this formula, so then you can able to solve the problems very quickly onto this. Clear? So how I got this formula? By solving these two, right? Now we'll solve one more problem here, no? Okay, same type of question, no? Similar type. So here right, same type of question here, no? So therefore here you will take it as mass m, here it is mass 2m, this also suppose it is m only, okay, you take it as m only here. Find out the acceleration of the blocks. So therefore here this same string, no, same acceleration will be there, but a different tension. Why? Because this wheel, whatever this, no, this wheel, no, it is given certain mass, not ideal one, no. If it is ideal, simple, our Newton's laws, no, you can solve these problems now. Again, just now I taught this question, no, I taught this formula. So similarly you can able to solve this concept now. Therefore what will be the acceleration now? So total force. What is the total force here now? Therefore, sorry here no, right, what is the total force here now? Total force is nothing but a mg sin 30. So therefore mg by 2, this side force, no, this side force is nothing but a 2 mg. Which is greater now? This is greater. So that means, so this side force, no, then you can, this it will go to here, no. Therefore how you can solve this problem now? Total force is nothing but a 2 mg minus mg by 2 by total mass of this one. No, total mass is how much? No, 2m plus m plus moment of inertia. We can take it as like a disc, no, we can take it as like a disc here, no. So I is equals to mr square by 2, I by mr square is nothing but a m by 2, that's all. You can solve this problem now. This is 4 minus 1, therefore 3 mg by 2. Clear? So this is 3 mg, therefore 6 plus 1, 7, 7 m by 2. So m by 2 get cancelled, 3g by 7 will be your acceleration. In this way you can solve the problems very easily by using this formula. Clear?